Okay, so here we assume that f of x is some polynomial. Here, I'm just going to choose a polynomial of order m. But m is something you got to figure out from maybe somebody tells you that, or if you have a hunch that second order, third order is good, you'll use that. Or sometimes you just have to try different things. So let's say that m is the degree of the polynomial. We then create the error term, which is going to be the summation I equals 1 to n. Let's call this y. Y I minus c0 c1x plus c2x squared. So then use calculus. Here we need to minimize e with respect to the parameters. The free parameters are c0, c1, and so on. So if you do this derivative, and I'm going to take a shortcut here, I'm going to write the simplified expression. There is one step before this, which I've ignored. You get yi minus c0 minus c1 xi minus c2 xi squared, so on till cm xm equal to 0. That's the derivative with respect to c0. The next one would be de dc1. That'll come out to be minus 2 I equals 1 to n. Okay, so when you take this derivative, you'll have the same, exactly the same thing as before. But in addition, you have to differentiate c1 x1 with respect to c1. So that will be x I is 0. Then you do the same thing with c2. Sorry, c2. It's going to be minus 2 I equals 1 and c so yi minus c0 minus c1 xi minus c2 xi squared, so on till cm xm, and the derivative of c2 xi squared with respect to c2 will be xi squared. Okay, we just keep doing that till we reach de dcm equals minus 2 summation I equals 1 to n yi minus c0 minus c1 xi minus c2 xi squared minus cm xm, and then take the derivative of cm xm with respect to cm. That will be x raised to m equals 0. Okay, so what we need to do is we need to rewrite these equations as a matrix. Okay, just very similar to the previous one where we had A and B. Here we'll have C0, C1, C2, C3. So I'm going to write down that simplification. N summation xi square, so on till summation xi raised to m, summation xi square, summation xi cube, so on till summation xi m plus 1. Then we have summation xi square, summation xi cube, summation xi raised to 4. Keep going till summation xi m plus 2. And you can see the pattern. It's basically, you just keep increasing the order. So you end up with xi raised to m, summation xi m plus 1, summation xi m plus 2, and so on till summation xi 2m plus, that's a 2m. Okay, so those are the coefficients whose values are known because xi basically comes from a data. And then we have C0, C1, C2, so on till Cm equals summation yi, summation xi, yi, summation xi square yi, and so on till summation xim yi. Okay, so what we have here is that's the A matrix. Let's call this the matrix B or vector B. And this thing here is C. Okay, A is known because it comes basically from a data set. B is known, it also comes from a data set because you're given xi, yi. C is the unknown. So we have A, C equals B. And so C equals A inverse B. So we got C. Okay. And then, of course, y equals C0 plus C1 x plus C2 x squared, so on till Cm x. So you've got this because now you've computed C0, C1, so on from that equation. Yes, I'll post it on Blackboard. What I would expect you to do is we will assume this polynomial. You need to obtain C0, C1, C2, C3. So we are aiming for AC equals B, and then C would be the inverse of A times B, where C is holding C0, C1, C2, and C3. Okay, so all I need is to get A and B. From the formula I wrote down a little while back, the previous page, you can see that it is summation xi square, summation xi cube, summation xi square cube. Just keep doing that for 3 rows in a row, for the 4 rows. These lines are just to show you that those are the rows and columns of that matrix. Okay, and then B is summation yi, summation xi, yi, summation xi square, yi, summation xi cube. Okay. And what you get after subbing in the values is something like this. 11, 0, 17.60. Actually, you know what? Let me write it column wise. 11, 0, 17.6, 0. The first row, sorry, first column, 0, 17.6. Okay, then we have 17.6, 0, 50 point. This should be, we're at 4 decimal places. 1248, 1248, 0. $168.0589. Okay. Okay, let's write B. I get for B the following. $24.4093, 57.1129, 75.3937, 182.2007. Okay, so C equals A inverse B equals 0279, 10453. Okay, so with that, we can write the equation for Y. It's minus 0.4279. That's the constant part, 1.0453 x plus 1.6544 x square plus 0.7724 x cube. The data is in blue, and then the fitted line is in red, and you can see that it sort of explains the trend in the data. That is, initially it starts off flat and then peaks, like what you would see in the type of data that is shown here. Now, obviously, the way I got to a third order polynomial is first there was data points, and then I looked at the data point and said, maybe a third order polynomial can explain this data, and I did this process. But if you are given with data like this, you might have to do second order, third order, fourth order, and then choose one of them which best explains the trend. So if I do second order, I'll get a different trend, different curve, and then you need to judge which of those you will choose.